The International System of Units, or the Système International, excuse my French accent, it's not very good. It's often abbreviated as SI units. So you might see it written as SI units. It's not S1, it's SI. And it comes from that system, it's international. So it's a modern form of metric system, and it's the world's most widely used system of measurements in science. So these on this page is used throughout the world, okay? So everybody is familiar with different shorthand ways of writing things and different units for things. So you went through this table, I believe, so you should have this written down already. So we always have a quantity that you measure, and it's measured in a certain amount, a certain unit. Okay. Now you might sometimes say it's smaller or bigger, but the System International SI unit is always the base unit for it. So for example, length, its SI unit is measured in meter, and that abbreviation is M. So you could measure length in kilometers or centimeters, but the base one is just meter. So that's the base unit, the SI unit for length. Something measured in kilograms, kg. Now, if you haven't done this before, I'll be tricking you because I think a lot of you might say weight, but weight is a different thing. So mass is measured in kilograms. Weight is actually your force. It's due to gravity. Okay, so what we say when we say weight, we're just speaking normally in English. So we say like weight watchers, or measuring the weight of that. What we actually mean is we're measuring the mass of that, because you're measuring how many kilograms something is. Weight is actually the force pulling you down to the floor, so you're not floating off. So just interesting to know not the difference between that. Time is measured in seconds. That's the base one, that's the SI unit. So you might get minutes, you might get hours, but seconds is the SI unit. And its abbreviation is S. So it's not SECS, no, it's just S. Okay? So never abbreviate it as SECS because that's wrong, always just the S. And I've added in an extra one here, just to make sure you remember that weight or force, because weight is a force, is measured in newtons, and that's capital N. So can you add that in if you haven't already? And there's a couple of points to note there. So you should only use the agreed abbreviations. So as I said, like S for seconds, not SECS. Full stops are never used at the end of a unit. So even if you're writing a sentence, no full stop at the end. And S is never used to indicate plural. So if you were going to write newtons, you just one capital N. You don't need NS, just one capital N. And symbols for units are written in lowercase except for symbols which come from the name of a person. So, for example, Newton, capital N, because it's named after Isaac Newton. The apple fell on his head. But the others are all in lowercase because they're not named after a scientist. Okay. Any questions from we did last week? Yes. Yes.
Does that mean that there was a person called Meter?
No. So that's just so that's why M isn't capital. So M is lowercase. So the reason that M is lowercase is because it's not named after a person. But a really good question. So anything that is named after. Okay, well that's a lowercase m because it's sort of rounded. Okay. Yes. Yeah. So the unit for force, which is tied in with gravity, is named after Newton. Oh, it could have been. It could be. I'm not entirely sure. That's something that I'll need to look into. Yes. Yeah. Yes, there are lots. There are Kelvin. So you know how Kelvin size, that's capital K. Watt. So there's a unit called watt, W-A-T-T, and that's capital W. Tesla, you know the cars? Well, that's actually a unit named after a scientist. It's also called Tesla, capital T. So there's quite a few of them. You'll come across loads. Okay? Right. So that's the units. Now we're going to look at something called prefixes. Okay? So prefixes are the things that come before the units. So it might be centimetre. So centi is the prefix before the unit metre. Yeah? Or kilometre, kilo is the prefix before metre. Yeah? So these things that come before the units are called prefixes. And they are, we've got 4 of them here that you're going to come across most of the time. So we've got multiple or fraction, name of prefix, and abbreviation. So mega, so if you had a megameter, you don't really get those very often. Mega is actually 1 million. So a megameter would be 1 million meters. So we'll write that in there. So 1 million. One million is a megameter, or 1 million newtons would be a meganewton. Yeah. Does anyone know what 1,000 might be? Yeah, kilo. Yeah, so 1,000 meters is a kilometer. So kilo. Okay, so centi, we've all heard of centimeters. Yeah? It's 100th with a th on the end because it's actually 100 times smaller rather than 100 times bigger. So we write it like this. 100th. 100th. So there are 100 centimeters in a meter. So a centimeter is smaller than a meter. And 1,000th is, yeah, milli. Millimeter. And just remember, again, that's a lowercase m, that's a capital N. So 1 million is a capital N, mega. 1,000, th, that's a 1,000 times smaller, is milli, lowercase m. Okay, so I might be testing you on these at some point. So it's really important to know all these, okay? Any questions from those? Yes? No. So really good question again, but it doesn't. The same thing doesn't apply. So there isn't a Mr. Mega as far as I know. It's just the fact just to differentiate between mega and milli. But yeah, really good question. It's a cool name though, wouldn't it? It'd be a cool name. Right. Okay. So we're going to move on a little bit and we're going to talk about variables. Okay, so when we do experiments, which we're going to do experiments in a second, we have to think about variables. So variables are things that vary, so things that change within your experiments. So things that are different. Yeah. 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 Or how do things change when you change something else? Yeah. So at your experiment, you always have to sort of think about what am I doing, what am I changing, and what's changing because of it. So when scientists work, they often have to carry out practical investigations. And this involves planning what experiments must be done and deciding what quantities or variables must be altered and controlled, and what observations must be made and measurements taken. So experiments must then be carried out carefully and the results presented in the best way. These results are then interpreted and conclusions drawn. So something that changes or varies during the course of an experiment is called a variable. So we're going to look at something very simple. So we're going to look at some paper shapes. Now they are out on the desk at the front and I'll let you have a look at them in a second. But I also just want to show you a picture of them as well. So that's the same things as are out on the desk. So you'll see there's a variety of different shapes. There's a lot of things that are different about all these shapes. There are actually 3 different things that are different. Okay. So what I want you to do is just take a couple of minutes, come up and have a look at them just on that front desk, and think about what are the variables with these. What are different? What's making them different to each other? So come up and have a look, just on the front desk over here. Once you've had a look, have a sit down. If you don't want to come up and have a look, you can just look at the screen. I took this photo earlier, but if you want to have a look at them, feel free. I just thought you might want to stretch your legs, but if you don't want to, it's fine. It's fine. So what's different? What varies? I'll let you think about it and I'll ask you in a second. You'll be heating some things up, doing some experiments. Don't do it as often as in chemistry. Because chemistry is every lesson. Right, okay, so what are the variables here? Yeah. Colour? Yeah. Yeah. Shape and size. Yeah. Right, so we're going to write that down in our notes. So back to my notes. There we go. So in the variables, we have colour, size and shape. Okay. So we've also got the values to the side. So if I go back to my PowerPoint, what are the values? So the shapes, it means what different shapes are there? Yeah. That's it. Yeah, square and triangle. So the values for our shape are square, and triangle. Okay. What about colour? Yeah. What about colour? Sorry. Yeah. Perfect. So colour, our values are blue, green, and red. We okay? And what about size? Yeah. Yeah, large, medium, and small. Let's say that. Good. So that's all about variables. There are things that vary within that experiment. So there was colour, size, and shape. And within those variables, there's even more things that varied. So colour, blue, green, or red. Size, large, medium, or small. And shape was square or triangle. Okay. Everybody got that written down? Anyone still? I'll just leave it up for a second. Are you okay? Right, so the next one we're going to look at is a similar kind of thing, but we're going to look at these sort of tubs in front of this desk over here. So, ignore the numbers, they're just to identify them. So, really, what you need to do, because you can't just look at these ones, so you do have to come over and maybe touch them, see what happens, lift them up, okay? So, again, come on, have a look at these, think about what variables in there. I'll put a picture on the board, but it won't really help much. Okay, have a seat once you've had a play with them. Okay, leave them, thank you. Okay. Listen. I'm still waiting. Thank you. Right, so I was listening in to some of the conversations over there. So I heard the words colour. I heard the word size, but I'm going to put that in a more scientific way and put volume. So size / volume, because volume's, same, the size of those. And what was the other one? What was the other one that varied? Yeah. At the back. Excellent. I thought you were going to say weight, and you said mass, so that's brilliant. I did hear some people saying weight, so that's why I wanted to just check. So remember, mass is how heavy something is. Yeah. So if we're talking about like how many kilograms something has, it's mass, not weight. Okay. Now, the values for colour, let me just remind you. What are the two values for colour? Red and blue. Size, what was the big and small? Yeah. We won't measure it out, we'll just say big and small, because there's only two different sizes, isn't there? You can put that if you want. And mass, we'll say heavy and light. Okay. Now, if we, I've heard some people already discussing this, which is brilliant. If we wanted to think about the pattern between them, the easiest way to do that would be to create a table. Okay, so you can see the table at the bottom. It says can number, colour, volume, and mass. Okay, so can number 1. I'll just do this in the front. Colour is red. Volume is pink. And I can tell you it is heavy. Okay. So red for heavy or blue? Maybe. So red, big, and heavy. And number 2. Colour is blue, volume, big, and white. Number 3, red, small, and it is heavier. And finally, number 4 is what colour? What volume? Small. And it is light. So, so we've got a table there that allows us to easily have a look at the pattern. So there's some questions at the bottom. It says, is there a link between colour and the mass of the canvas? So I want you to have a think about that. And have a think about, is there a link between the volume and mass of the canvas? That means, is the volume big? Is it necessarily that the mass is big or things like that? So have a think about those two questions. I'll give you a couple of minutes. Okay. Is there a link between the colour and the mass? Yep. Yep, exactly. So the reds are heavy, blues are light. Yep. And is there a link between volume and mass? Let's go for someone on the back table. You can say no. Yeah, no, there's no link. Because you can see there's a big one that's heavy, there's a big one that's light. So there's no link between volume and mass. In this experiment, yeah, colour is the thing that affects something else. Okay, very good. Right, has everybody got that written up? Okay, so now we've got to grips with variables. We know that variables are things that vary in experiments, okay? So things that change in an experiment. Now we're going to talk about specific types of variables, okay? So, two variables. So we're going to do some experiments today that involve two variables. We okay? Good. So when you change one thing, what happens to something else? That's what we mean by two variables. So one thing that you change, and then something that happens that changes because you've changed the first thing. Okay. Now these are special, there are special names for these variables, and you can see here, one is an independent variable, and one is dependent. So the independent variable is the thing that you have control over. Okay, the thing that you are changing to then see what changes because of it. So the independent variable is the one that you alter yourself. The dependent variable depends on what you do, depends on what you alter. So it might be that you're pushing a car down a slope. Okay, so you push a car down a ramp. Okay, so it might be that you change the height of the ramp. So you are controlling that. That is your independent variable. You decide how steep a ramp is. And then you might be measuring the speed of the car down the ramp. So because you changed the height or the steepness of that ramp, how fast is it going? So the speed or how fast it's going is the dependent variable. It depends on how steep that ramp is. Okay. So we're going to do an experiment with a spring balance. Now you've all seen a spring balance before and you've played around with them a little bit, but we're going to do a proper experiment with variables now. So what we're going to do is you should all have a spring balance on your desk. When I finish it, you will need to come against one of these. Okay, so these are called masses or slopes of masses. And what you can do is you can lift them up and pull up them up using the flat bit of the holder, like that. Because we're starting with 300 grams. So that means that is your holder. Okay, that is 100 grams. To get 300 grams, that's 200. And that is 300. Okay, and you're going to get your spring balance, and you're going to hang that 300 grams on there, read off the number that it settles on. Bounce it down a little bit first, so you wait till it settles. And I've got it at about 3 there. Okay. So I would write down force needed to lift mass 3. But yours might be different, so don't necessarily do what I've done. And then you're going to add on another one. 400. And read off what it says. Another one. And another one. Another one. Until you get to 1,000 grams, which should be all of them on there. Yeah? And you're going to write in the table the value that you're reading from that spring balance. Now, before we start, we're going to have a look at just the questions there. What are the variables? So what are you changing? And what are you reading? What are you measuring? Yeah. The mass, yeah. So you're changing the masses. And then what are you measuring? Yeah. Exactly. So the independent variable is the thing that you are changing. So you're changing the mass. Yeah, I heard somebody say it, mass. So that means the dependent variable is the thing that you're measuring because you've changed something else. So that must be force. Yeah. So I'll let you do the experiment, then I'll let you fill in the conclusion yourself because you should come to a conclusion. Okay? So you've got a spring balance on your desk. You just need the